All right, 11.3a notes. Tomorrow we're going to do the 11.3b notes. Friday we're going to review, and Friday, remember, is our little no calculator quiz. Ooh, actually, since I've got this up here, before I go on to the notes, I want to show you, I posted a short optional review. Optional meaning I'm not going to be collecting it. This is tonight's homework, and I'll attach the video when it's done. But right here, optional practice for Friday's short quiz. If you click on it, here is your optional practice. Short practice for a short quiz. Your quiz is going to look just like this, just with 3 lines of this chart. Okay? Different numbers most likely, but the same ideas, right? The answers are down here if you want to check yourself, but that is on Google Classroom if you want to prepare yourself for Friday. Okay? What else is coming up? Group test is Monday. Individual test will be next Thursday. Would have been next Wednesday, except next Wednesday is career fair, so we have to wait. All right. So.
Chapter 10 isn't on it.
Nope. It's all Mod 11.
Said that yesterday if you're listening.
So.
I wasn't paying attention.
Oh, we know.
We have equations today instead of expressions. What does that mean? There's an equal sign. Okay? So, we've done equations like this, and how would I solve an equation like this? I would square root both sides, meaning that my answer would be x equals what? X equals what? Positive or negative 5. Right? We've done those. Now we're going to go the other way. Instead of having a squared and needing to take a square root, I'm starting with a square root, which means I'm going to have to what? Square it to get it to cancel out. So I have my radical. I'm going to square it. That cancels. X equals 25 squared.
625, I believe. Yeah.
25 squared is 625. Now, one thing about these equals signs problems, these equations, is we always have to check our answer to make sure it works. Okay? Because these can have extraneous solutions. Excuse me. When did we have extraneous solutions before? When we had those problems with fractions and we had to check to make sure that an answer didn't make a denominator equal to 0. Now, we don't have denominators, so I'll show you what it would make it, what it would do to the problem if you had an extraneous solution. So, checking my answer, I'm going back to the original problem. The square root of x, but I'm saying x is 625. Is that equal to 25? So let's see. Square root of 625 is 25. So the square root of 625 is 25. Both sides are equal, therefore I have a true statement, and my answer is valid. Okay? So, for a valid answer, both sides must be the same. That's what I just showed you. Okay? All right, let's try the next one. Little bit more complicated. So I'm going to have to start going through some of these steps over here. Step 1 is what? Get the radical alone. So that means, like in this problem, on this side of the equal sign where the radical is the radical the only thing over there? Everything on this side, is it a part of the radical? The 25 is a part of the radical because it's still under that little radical house, right? So my radical is alone. There's nothing else over there. So I'm ready to square both sides. And when I square this, I get x plus 25 equals what? 16. So what would I do now?
Subtract the 25. Oh, yeah.
So x equals what?
Negative 9.
Do I need to check my answer?
No.
Mm-hmm.
You could.
You have to check your answer. Negative 9 plus 25 under the radical, does this equal 4? What is negative 9 plus 25?
16.
Does the square root of 16 equal 4? So is my answer good?
No.
Okay. All right. The next box, right below there. What's the difference between these two?
Negatives.
No.
One is cube.
One is a cube root, one is a square root.
Come on, buddy.
We square roots. What do you think we do to cube roots? We cube them. What do you think we do to fourth roots? You fourth them. You raise them to the fourth power. What do you think you do to fifth roots? You raise them to the fifth power, and so on and so on. So the power you are raising both sides to has to match the index of the radical. Okay? So my radical is by itself, right? So I'm going to square both sides. And what does that give me? X equals 4. So now let me check my answer.
No.
The square root of 4, does it equal negative 2?
Right.
But Mrs. Franken, isn't the square root of 4 both 2 and negative 2? Yes, but there's a problem with that. Here's the deal. That plus or minus only comes into the problem when you are putting the radical in there. When the radical is already in the problem, they're asking for whatever the sign is in front of it. So there's no sign there, which means it's positive. So they're referring only to positive 2.
Therefore, it's wrong.
So that does not check out. My answer cannot work. So what do you think I need to write?
4i.
No solution.
Oh, man.
No solution.
I just put NS.
You can write no solution. Okay. All right, this one right here. What do I need to do to both sides? I'm not squaring it. So my cube root and my cube cancel out. And negative 2 to the third power is
-8.
negative 8.
Come on, Dylan.
Does this check out? Does the cube root of negative 8 equal negative 2?
Yeah.
Yes. Why do you think that is?
Because negative 2 times negative 2 was 4. 4 times negative 2 is negative 8.
Well, yes. Do cube roots ever have to deal with a plus or minus? No. But square roots do. Do fourth roots have to deal with a plus or minus? Yes. Do fifth roots have to deal with a plus or minus? No. So what kind of a rule could we come up with there?
All evens.
If you are dealing with an even index, a square root that you have to square, a fourth root that you have to fourth, okay? You have to check for extraneous solutions because the plus or minus is where the issue comes in. If you have a cube root, you don't have to check your answer. You can if you want to make sure it's correct, but you don't have to check for extraneous solutions. Does that make sense? And that's kind of summarized right here. If you remember this, you can save yourself some time. On radical problems, you only need to check your answer on the even index problems. Again, if you forget that, check all of them. It'll cover your bases. But if you remember that, you can save yourself some time on some. So, if I were to look at this one, am I going to need to check my answer here? No, because it's a cube root. Odd index. All right, so I have to start with step 1, which was what? Get the radical alone. So what do I need to do? I need to subtract 1 here. So I have 2 times the cube root of x minus 3 equals 4. What would I do next?
Why didn't you do the exponent first?
There is no exponent. Good point, though. You have to be careful. That almost looks like 2 to the third, doesn't it? It's not, though. It's a cube root. So on a test or something, if you're unsure whether it's an exponent or whether it's on the radical, come ask me. So how do I get rid of that 2? Because it's being multiplied by the radical, right? So I'm going to divide it. That gives me the cube root of x minus 3 equals 2. Now can I cube both sides? So cubed, x minus 3 equals what? 8. Add 3, And what does x equal?
11.
Do I need to check my answer?
No.
Why not? Because it's a cube root. Can I check my answer if I want to know that I did it correctly? 11 minus 3 is 8. Cube root of 8 is 2. Times 2 is 4. Plus 1 is 5. It works out. Okay? All right, next problem. Next problem here. Is my radical by itself?
Yes.
So I'm ready to square both sides. Am I going to have to check my answer? Yes, because I have a square root and that's an even index. Square root cancels the square. So x minus 6 equals. Now this is a problem where people tend to lose a lot of points. I can't tell you how many people turn this side into x squared plus 64. Because what you're trying to do is you're trying to use one of the exponent rules we learned yesterday and apply it to this situation. Now, the rules that we talked about yesterday, the only ones where you could actually distribute an exponent was one where there was one base. We do not have that circumstance in this problem. We have two bases. If the bases were being multiplied, we do not have that circumstance. Where else? If they were being divided, we do not have that circumstance. We don't have any of these situations, so we cannot distribute an exponent. You've never been able to distribute an exponent to this. Whenever you have addition or subtraction in there, you actually have to write it twice and FOIL it. Okay? If you try to just distribute that exponent, you will be missing an entire term, which will make everything wrong. It's yucko. So, x times x is x squared. X times negative 8. Negative 8 times x. And negative 8 times negative 8. And my x minus 6 over here is just staying as it is. Okay? So, let me simplify this a little bit further, because I can combine those guys. But x squared minus 16x plus 64. Now, where am I going?
You add the 6.
Why?
Because you want x by itself? Or
Mm,
am I stupid?
well, there's x here and there's x there. Why would I want x by itself? It would be really hard to get it by itself because there's two x's and there's an x squared.
Combine like 2 and 10.
I am going to be working towards, I heard someone say it,
The left side.
snowflake. I'm going to need to factor. I have an x squared, so I'm going to need to factor.
Oh, God.
So, that means I need to move everything to the same side as the x squared. So I'm going to move the x by subtracting it. And if it's okay, I'm going to move the 6 in the same step just to save some time.
That's what I said.
So 0 equals x squared minus 17x plus 70. So if I factor this, 70 and negative 17, what are two numbers that multiply to get 70? Negative 7 and negative 10. What goes on the top? So 0 equals x minus 7, x minus 10. What's my answer here? X equals 7, and from here, x equals 10. Do I need to check my answer?
Yes.
Yes, because it was a square root. So I'm going to start off with the 7. Does the square root of 7 minus 6 equal 7 minus 8? Well, 7 minus 6 is 1. 7 minus 8 is negative 1.
No solution.
1 does not equal negative 1, does it? So 7 is not a valid answer. That does not make it no solution. I haven't checked 10 yet. So now I'm going to check 10. Square root of 10 minus 6. Does that equal 10 minus 8? Well, 10 minus 6 is 4. 10 minus 8 is 2. That one does check out. So my only good answer is x equals 10.
So wait, why didn't you write no solution if you said
Because no solution means that no answer is good. I have a good answer. That one is not the good answer, but I still have a good answer. You only use no solution when all of your possible answers are extraneous, when they all get knocked out. Okay? All right, turn the page.
Wait, like 5 seconds.
Waiting 5 seconds. All right, backside. We got 2 problems here. So, I have a radical on both sides. 2 radicals. I cannot get both of them alone because one has a 3 on it. And if I tried to get rid of that 3, I would have to divide both sides by 3, right? Dividing both of them by 3 would move the 3 over to here, and it would make it a fraction. So I can't get rid of that 3 yet. When I have 2 radicals, if I can't get both of them by themselves, then I need to at least get one by itself. Is one of them by itself? Yes. So as soon as one of them is by itself, I can square both sides. Am I going to have to check my answer? Yes, because this is an even index. Now this side should be pretty straightforward. Square root cancels, so I have x plus 11. This side, however, I now have multiplication inside the parentheses. I have 3 times this square root. Multiplication inside, I can distribute an exponent, which means I have to square both the 3 and the radical 2x plus 5. So 3 squared gives me 9, and when I square the radical, I just get 2x plus 5.
You don't square inside it?
No, because when you square root 2x plus 5, and you square that, you don't get 4x squared plus 25. You just get something that doesn't have a square root anymore. Okay? All right. So I'm going to distribute the 9. I get 18x plus 45 equals x plus 11. And where am I going here? I'm trying to get x by itself, right? There's no x squared, so I don't need to worry about factoring. So I just want to get my x's together and alone. So I'm going to move the x over here by subtracting it. 17x plus 45 equals 11. What should I do now? Subtract 45. And 17x equals negative 34. What do I do now?
X equals -2.
Divide by 17. And I get x equals negative 2. Do I need to check my answer? Yep. So, the original problem, 3 radical 2 times negative 2 plus 5, all that's under the little radical house, is equal to negative 2 plus 11 under that radical. So I got to see, do both sides of the equal sign end up being the same thing? Well, which side's easier to simplify first? The right side. Negative 2 plus 11 is 9, and the square root of 9 is 3. So now I just got to see if all this ends up as 3. So inside, I have 2 times negative 2 is negative 4 plus 5. What is negative 4 plus 5?
1.
1. What's the square root of 1?
Negative or positive 1.
So does 3 times 1 equal 3?
Yeah.
So my answer is good.
But what about the negative 1? Like, don't you have to use both and like toward, you know what I mean?
Nope.
Like, the square root of 1 is negative and positive 1.
Remember, unless there's a negative in the original problem, you're assuming they're talking about the positive one.
Okay.
So the square root of 1, yes, it's positive and negative 1, but because there's no negative out in front in the problem, they're only asking for the positive one. Okay, questions there? Yes.
So you only factor when you're doing x squared?
Yes, because you can't do a snowflake with just a plain old x. Okay? All right, this last one is a little bit longer. It's not bad. It's still multiplying, combining like terms, that kind of stuff. We will have to factor this one. But the good news about this one is the fact that I will not have to check my answer because it's cube root. So I don't have to check my answer. Once I'm done, I'm done. So is my radical by itself? Yes. So I can go ahead and get ready to raise both sides to the third power. Cube root and the cube cancel out, and I'm left with 26x to the third minus 1. And then what do I have to do on the other side? I have to write 2x minus 1, 2x minus 1, 2x minus 1. Now, I don't want to hear any whining about this. You've done multiplication like this since like 6th grade. Okay? We're going to be grown-ups and deal with this. So, 2x times 2x, 4x squared. 2x times negative 1, negative 2x. Negative 1 times 2x, negative 2x. Negative 1 times negative 1, positive 1. By all means, if you want to use the box method, use the box method. Okay? I happen to be more comfortable with doing it this way. So let's see. I still have 26x to the third minus 1. Haven't touched that yet. And this was only 2 of the 3 parentheses. So once I simplify that, I still need to multiply it by another 2x minus 1. Now I don't want to multiply it yet because, why? I have some like terms I can combine. Do you see this? Minus 4x plus 1, because if I can combine those like terms, it gives me one less thing I have to multiply. And I still have this 2x minus 1. So now I'm going to do this multiplication. 4x squared times 2x is 8x, thank you. 8x cubed. 4x squared times negative 1 is negative 4x squared. Negative 4x times 2x is negative 8x squared. Negative 4x times negative 1 is positive 4x. Positive 1 times 2x is positive 2x. And positive 1 times negative 1 is negative 1. Other side has 26x cubed minus 1. Let's see, I think I have some like terms to combine. I have 8x cubed, and then what have I got here? Minus 12x squared. Here I've got plus 6x minus 1. All right, now what do I do? Where am I going? I have a feeling I'm going to have to factor, probably. How many answers do you think I'm going to be looking for? 3. How do you know? Because the highest exponent is a 3. Remember that? So I'm going to be looking for 3 answers here. These are good things to know as you're going through the problem. So I'm looking for 3 answers. I'm going to have to factor somewhere. With a cubed, that makes me think grouping potentially, unless there's something else going on there. But where do I want to move everything? I can't do any of that until everything's on the same side of the equal sign. Do I want to go to the left or to the right? I would love to go to the right because all the terms, well, most of the terms are already there. However, if I go to the right, what does that do to my leading coefficient? It makes it negative, and you never want to try factoring with a negative leading coefficient. So even though it's quicker to go to the right, we're going to go to the left. Okay? So I'm going to start off by subtracting 8x cubed from the 26x cubed. Okay? In the same step, if it's okay with you, I'm also going to add the 1 because that also has a like term over there. What do you notice about adding the 1? It cancels on both sides. Interesting. So I have 18x cubed equals negative 12x squared plus 6x. Well, now I'm just going to move these guys over. I'm going to add 12x squared. And I'm going to subtract 6x. Again, I'm just going to do it all in the same step to make it easy. Now, even though I listed these on top of each other, they are not like terms. So I cannot combine the 18, the 12, and the 6. It has to be written as 18x cubed plus 12x squared minus 6x equals 0. Okay? What was that? Okay.
Take it out.
What can I take out?
3x.
I can take something bigger than 3.
6x.
I can take out a 6x. What's left inside? 3x squared plus 2x. Now, I said I was going to have 3 answers. My first one's going to come from right here. Because if I set 6x equal to 0, and I divide by 6, what does x equal?
0.
There's my first of 3 answers. The other 2 answers I'm going to get from this second degree polynomial in the parentheses. Right? 2 answers from a second degree. Make sense? So, I'm going to need to factor that. So I'm going to come over here and give myself some more room. 3x squared plus 2x minus 1 equals 0. And if I snowflake that, what goes on the top? Negative what? 3. 3 times negative 1. What goes on the bottom? What are 2 numbers that multiply to get negative 3 and add to get 2? 3 and negative 1. What goes on the top? 3x and 3x. This one reduces to what? X over 1? That one doesn't. So what are my 2 parentheses? X plus 1 and 3x minus 1. So from here I get the answer what? X equals negative 1. From here, what do I get? 1/3. If you can't see it right off the bat, then do the work for it. Add your 1. 3x equals 1. Divide by 3, x equals 1/3. So 3 answers. 1, 2, 3 answers. I do not need to check them because it was a cube root problem. Okay? Homework's right here. It is on Google Classroom for you to look up. Okay? Happy studying.